Hello everyone, back tuning into our 12th Winter 2020 update part 1. So here we go again, it's Sunday, and we're going to bring you another winter update, and in fact we are coming to the end of winter updates now, so once this one is done, we've only got one more to do next week, the 13th winter update, and then that is it. We are out of time, and after that, on Wednesday the 2nd of December, we will be releasing the GavsWeatherVids.com Winter 2020-21 forecast. So, I mean, to say we're at the business end of winter updates is an understatement, and we're about to run out of time on these winter updates, and very, very soon we will be able to do no more for you other than bring you our winter forecast. But we have still got this update to go, and we've got next week's 13th update to go to. Both of these updates will be in two parts. So again, this is part 1 of the 12th winter update. Tomorrow we'll have part 2, which will be focusing on our analogs, and then next week, of course, we've got the 13th winter update in 2 parts as well. So sit back, relax, and enjoy, and I'll talk you through the 12th Winter 2020 update part 1 very shortly. Just say thank you so much to Richard for the fantastic winter updates gift. Been one of your best, Rich. So thank you so much, everybody, for all of the lovely comments that they've been giving to Rich over the past few weeks about the winter updates gift. It's been fantastic. I know so many of you have enjoyed it. You give me so much positive feedback that I passed on to Richard about winter updates gift. So thank you so much, both to Richard for creating the gift and also to all of you for all of the lovely messages about the GIF. So I've got to say thank you to Richard for that, and also for the help with the 12th winter update as well, and also to Shryan Bruin, and also to James Ackrill, and as we get to the sections where they have helped with the update, but of course I will tell you where they have helped us, and what they've done. So thank you so much to Richard, to Shryan, and to James. It's going to be quite a long video, as always, with a long range stuff, so you can't watch it in one go. Don't worry, it will be put on the winter updates page at GavsWeatherVids.com with a written summary, and you'll be able to have a read about, watch the video on demand, either at the website or at the channel, whenever you would like to do that. And I'll get that up for you probably tomorrow morning. I imagine I'll be quite tired tonight, so I'm going to do part 2 of this update tonight as well. So I will think it'll probably be tomorrow morning that I get this onto the winter updates page with a written summary, but it will be placed there eventually. What else I've got to tell you? So, coming up later on today, around 3-ish, I think we're going to have the E70F Mesh France DWD and JMA long-range update. That's getting all of those long-range ones together, see what they're all showing. The winter, that's ahead of next week's final season model roundup, Winter 2020-21, of course. I'm going to be live streaming at 6, so we'll have a live stream at 6 o'clock. I think we're only going to run this for an hour. This week, so it'll be a live stream from 6 until 7, and so look at like short range ones, and we'll also be looking at CFS as well for winter 2020-21. We're going to look at some winter data with CFS B2, and that'll be coming up from 6 to 7 o'clock this evening. So I shall see you then live, won't I? So sit back, relax, enjoy, get yourself a cup of tea, some nibbles, and we're going to begin the 12th Winter 2020-21 update, part 1. And we're going to bring you, first of all, the updated swingometer from our King of Swing, Richard Traut. So you'll remember, of course, where we left off with last week's 11th update was with the analogues of winters following hyperactive hurricane seasons and big hurricane seasons, and so the swingometer takes that into account, and also the rest of the 11th winter update. So I'm going to show you it right now. This is the updated swingometer for the winter of 2020-21 up to the end of the 11th winter 2020-21 update. Here it is. And the swingometer is favouring a colder than average winter. Look at this. There's been a massive swing. There's been a massive swing from mild to cold, and so the swingometer is now favouring a colder than average winter by 52% to 48%. Yes, the swingometer has swung dramatically. As the king of swing himself has put it, huge swing to cold, huge swing from mild to cold from last week. And so as of the end of the 11th Winter 2020 updates, the winter updates are now favouring a colder than average winter by 52% to 48%. Wow, what a massive swing that has been. Thank you so much to our king of swing, Richard Traut, for keeping the swingometer updated. And of course, you'll find out, you're going to find out next week how this 12th update moves things, if indeed it does. We may not get a swing, remember. It's possible the swingometer will not swing at all. But you'll find out next week anyway how this 12th winter updates in 2 parts has moved the swingometer. But certainly up to the end of the 11th winter update, a massive swing from mild to cold means that we are now favouring by 52% to 48% a colder than average winter with our winter updates. Thank you so much, Richard, for sending that through. Okay, so we're going to begin this 12th Winter 2020 update with the Arctic Oscillation. So this is how the AO observed and forecast chart is looking from NOAA. So remember, the Arctic Oscillation is an index that's reflecting the atmospheric state, not driving anything. So in terms, it just tells us what the atmosphere is doing. When the AO is in its positive phase, then we're favouring low pressure over the Arctic. When the Arctic Oscillation, though, is in its negative phase, we'll be favouring high pressure blocking over the Arctic. Blocking is the route getting colder out of the pole down into mid-latitudes. The black line shows we're a bit with the NAO, with the AO. The red lines at the end show where the AO is being forecast to go. We're currently very positive with the Arctic Oscillation, meaning that we've got a lot of low pressure and a strong polar vortex at the moment. The GFS ensembles are forecasting the AO to reduce, so it's not going to be as positive as it currently is. Nevertheless, the GFS ensembles are forecasting the Arctic Oscillation to stay in positive territory, albeit at a somewhat reduced note. Now, by the start of December, just there, right at the very end of the chart, by the start of December, we may be seeing signs of the AO beginning to reduce to neutral or possibly to weekly negative territory. But of course, that's a very long way out, so the auxiliary range of the GFS and its ensembles, a more reliable time frame, it looks like the AO for the rest of November anyway, is going to be solidly in its positive phase. Okay, so the NAO also looking like this. So again, the same idea. The black line shows we've been with the NAO, red lines at the end, where GFS ensembles are forecasting the NAO to go. At the moment, the North Atlantic Oscillation is in its positive phase as well. So we have both indexes, the AO and the NAO, in their positive phases. The GFS ensembles for the next week are forecasting the NAO to stay positive, but then reducing as we go up towards the beginning of December and into the early part of December, seeing the NAO reducing into negative territory. So it looks like the NAO might be trending towards negativity, whilst the AO reduces from being very positive to like just more generally, more sensibly positive, to possibly going negative by the beginning of December. Both those indexes are moving though by the start of December, so we need to keep a watch on that and see where that's going. This is how things are looking in terms of the temperature at 10 HPA over the North Pole in the stratosphere. This is from a JMA. So the black line shows where we currently are. The temperature at 10 HPA, the grey line, is the trend line. So you can see that at the moment we're colder than average, but not excessively so. But we are a little bit colder than average with the temperature at 10 HPA in the stratosphere over the North Pole. Of course, it is a cooling time of year. The grey line shows that. But we're a little bit below par, but not excessively so. However, if we go a little bit lower down to 30 HPA, this is a bit closer to the troposphere, you see we have got a very cold stratospheric temperature there. We're approaching minus 80 at 30 HPA. So compared to like seasonal trend, it's actually colder near the troposphere than it is in the stratosphere, where we're closer to average, if you see what I mean. But both 10 and 30 HPA are colder than average. So this is how the zonal winds are looking from earthnullschool.net. So at the moment, zonal winds are positive. Now, of course, at this time of year, I explain this all the time, the black line shows like the trend. So at this time of year, zonal winds are getting stronger at the same time as the temperature is getting colder. So as the temperature gets colder in the stratosphere over the North Pole, that powers up the stratospheric polar vortex, and that means that the zonal winds pick up, and we can see the zonal winds strengthening on average at this time of the year. Now, you can see that at the moment we are stronger than average with the zonal winds. We're just there. The blue line is like this season. GFS ensembles, which are these green lines just here, are forecasting zonal winds to really power up in the stratosphere over the next couple of weeks. So you're going to have a very, very strong zonal wind, possibly record-breaking strong, as we come into the early part of December. We're going to have record-breaking strong zonal winds, which you would think is going to really power up the polar vortex. It's possible that we might see the polar vortex really, really powering up. Let's see how the CFS V2 expects things to develop. So from here on in, CFS V2 is basically, and that's these blue lines, basically forecasting zonal winds to decelerate as we go through December. This is December, of course, just here. So forecasting like a deceleration of zonal winds through December, possibly resulting in a reversal of zonal winds as we go into January, late December and into January. That might be associated with a sudden stratospheric warming. However, there is a bias at work within the CFS V2, it's believed. So if we put in the bias corrected, you can see that it looks like that. Still generally, even with the bias corrected, actually it looks like the CFS is still forecasting zonal winds to weaken as we go through December. Maybe not as dramatically so as the raw CFS output is suggesting, but nevertheless, it looks like even the bias corrected is seeing a reduction of the strength of zonal winds from that near record breaking or possibly record breaking level that it will be at around the beginning of December. So possibly the strongest part of the zonal winds, for this winter will be right at the very start of it. We'll have to wait and see about that. This is how the GFS model is forecasting zonal winds for the next couple of weeks. So, of course, this blue area, not zonal winds, the temperature at 10 HPA, I should say. So, this blue area is where we've got those cold temperatures at 10 HPA. Remember, we're approaching around minus 75, something like that. We're at metroshield.fr with this. So, let's see what GFS is forecast to happen with the zonal winds over the next week to 10 days. And if anything, they're going to get the temperature 10 HPA. If anything, they're going to get colder, going down to around minus 80 at 10 HPA. That's significantly colder than average with the forecast strength of the zonal winds. Right, let's see what happens after that then. So we're looking to see if we get a warming of the stratosphere. We're looking to see if we start to warm the temperature up at 10 HPA. Let's see if we get any warmer of the temperature at 10 HPA. Not really. Looks like the temperature getting even colder, going down possibly to around minus 85, maybe by the beginning of December on this GFS forecast. So that's a very cold stratospheric temperature, possibly going down to like minus 85 or lower at 10 HPA with those temperatures, which on this chart, whoops, I want to go there. On this chart would see the black line going down to around there somewhere. So by the start of December, it looks like we could have a very, very cold zonal wind indeed. It's only a forecast from a GFS, from a GFS. It may be wrong, but that's what the GFS is showing. I haven't shown you this before this season, but of course, if you've been watching videos over years, you'll know what this is. Again, this is stratospheric temperature at 10 HPA, but this time it's from the ECMWF via the University of Berlin. Now, helpfully on this chart, we actually have the North Pole itself highlighted. So there's the North Pole just there, that black X. Essentially, this is for the 24th of November at 96 hours. So essentially at 96 hours, again, the ECMWF is forecasting a very, very cold temperature at 10 HPA going down to around minus 70, minus 75. This is how things look in 240 hours, which gets us to the 30th of November. This is the ECMWF forecast for 10 HPA in 240 hours. Again, there's the North Pole, indicated by that black X, and the blue colours are still there. If anything's getting a little bit colder, possibly going down to around minus 80. So I think both the GFS and the ECMWF are seeing the temperature at 10 HPA getting ever colder over the next week to 10 days. This is how zonal wind and fluxes are looking via the University of Berlin with that ECMWF run. I think I zoomed in too much actually there, so let's pull this out a little bit. So this is where the zonal wind is at 1 HPA. That's at the very, very top of the stratosphere, right as far as you can go. At the very, very top of the stratosphere, 1 HPA. Very strong zonal wind then. And like in 10 days' time, as far as we go with the ECMWF, again, we see a little bit of a reduction in strength of zonal wind at 10 HPA, but still really, really strong. Down here, the blue and red lines, they are the zonal wind at 30 and 10 HPA. Remember, 10 HPA is higher up than 30 HPA. 30 HPA is nearer to the troposphere. They're both strong, though. You know, at the moment, zonal winds are stronger than average at both 10 and 30 HPA. And particularly at 10 HPA, but also at 30 HPA too, the ECMWF is forecasting zonal winds to become ever stronger. So from a stratospheric perspective, it does look as though the zonal winds are really going to be powering up. You haven't seen this before either, but I thought we'd just include this in this little section looking at zonal wind data and, you know, stratospheric data. So this is the extended zonal wind 10 HPA forecast from the ECMWF, and this takes us all the way into early January. Takes us all the way to early January. You can see how the zonal winds is the blue line just here, like the ECMWF ensemble plume, and you can see how the ECMWF is powering up. ECM model is powering up zonal winds by early December with a very, very strong zonal wind, really, really strong zonal wind through the early part of December. But as we go later on into December and then through to January, notice a lot of these blue lines, a lot of them are reducing and showing like a deceleration of zonal winds, which will be in line with what CFS V2 is showing as well. So the ECMWF wants a very, very strong zonal wind for the beginning of the winter in early December, and then a reduction in zonal winds. In fact, by the end of December and the beginning of January, some of these ECMWF ensemble plume members are going for like a reversal of zonal winds, which will probably be associated with a sudden stratospheric warming. That's where they've got to get to show a reversal. So we do have a lot of scatter there, but you can see from the ensemble image, which is this thick blue line just here, you can see that through December, after a very powerful start to zonal winds, it does look as though the zonal wind will be reducing, and yeah, we may be seeing the first signs perhaps of a reverse of zonal winds there as we come to the end of December and into the beginning of January, which would be associated probably with some sort of a sudden stratospheric warming. You'll be seeing a lot more of all of this stratospheric data in the videos, you know, as we go into the winter. I've been holding it back and holding it back and holding it back, but gradually, you know, gradually revealing more and more. And now we're virtually at winter, it is time to reveal it all. We've revealed all there. Gavs revealed all as we're coming to the very end of the winter updates. We're starting winter itself, and so you are going to see much, much more of that, all of that, as we go into the winter with our regular 10 to 14 day video updates. Right, that's part one, or the first part, I suppose, of the 12th Winter 2020 update, part one. Complete. I'll pause the video there. You go and, you know, stretch your legs, get yourself a cup of tea, get yourself a cup of coffee, whatever you like, maybe a glass of wine, maybe a glass of mulled wine. It's getting closer to Christmas. Whatever you like when you're watching the winter updates. And a few nibbles as well, perhaps a mince pie. And we'll see you back here in a couple of minutes or a couple of seconds. And we'll resume the 12th Winter 2020 update part one. I'll see you soon. Okay, we're back. And we're ready to resume the 12th Winter 2021 update part 1. If you've enjoyed the video so far, then please can you give us a like, let us know in the comments what you think, and make sure you subscribe to the GavsWeatherVids YouTube channel. We're on the grind to 9k subs, by the way, so it would be lovely to get there, you know, through the winter, and hopefully we'll be able to. Thank you so much, everybody, for doing that. Right, okay, so let's resume then. So we're going to carry on now with part one of the 19th Winter update, we're going to start this section looking at solar activity. So this is how the solar disk is looking on our side of this today from solarham.net. We've got 2 sunspot regions, one just there and a bigger one just there. Solar activity is at low levels today and is expected to remain at low levels for the next 3 days. Notice this is low levels though, not very low levels. How many times have I sat here and told you that solar activity is at very low levels? Well, today it is not at very low levels, it is at low levels and is expected to remain at low levels. And that tells us that we are having a little bit of a tick up in activity compared to what we have seen over the past few months. This is how the GavsWeatherVids Solar Activity Tracker is looking as of the 22nd of November, updated by our good friend James Atquill. Thank you so much, James, for updating this. So the orange line is depicting each individual day's worth of sunspot activity. And the thick green and thick red lines are our trend lines. So you see that we have gone through, when we explained this last week, we've probably gone through our most active period of conditions with sunspots on the solar disk, probably since sort of 2018, possibly early 2019. But certainly, we've been through quite a pronounced period of activity. We are still coming out of solar minimum though, so not going to be continuous activity all the time. We will still get days that don't have any sunspots. We have one of those. You can see that from the orange line just there. We had just one of those earlier in the week, but now solar activity is ticking up once again. And so that is why solar activity is at low levels rather than being at very low levels. Now, our thick green and thick red lines have moved upwards as well. So there are trend lines. They've been moving up, as we've been explaining. Although, over the past few days, they have kind of flattened off a little bit. They're flatlined a little bit. But if we're going to see more sunspots, we'll probably see the thick green and thick red lines continue to tick up. Solar flux, which is like the noise, the noise that's been emitted by the sun, that is also the sun's activity, that is also lifting up as well. So it all tells us that we're moving into solar cycle number 25. As you expect, we're a year into solar cycle 25 now, virtually, and you would expect things to be moving. And in fact, we're probably still at a reduced level, actually, compared to what you would expect at this point in a normal solar cycle. This has been sent through by a good friend, Richard Traut. Well, we've got Coruscant there from Revenge of the Sith. Thank you so much, Rich, for giving us a Revenge of the Sith gift with the Tantive 4, or the Blockade Runner, as it eventually becomes known. Yeah, that's a Revenge of the Sith, of course. Right, okay, so I'm off on a tangent with that. Sorry about that, everybody. I love a little bit of Star Wars. Right, so this is showing spotless days and the current spotless stretch. So the current spotless stretch is actually 0 days. So I'm going to try and work this out. So it's a little bit blurry, isn't it? My eyes, I don't know. So for 2020 so far, we have had 206 days, I think that is, without sunspots. That is 63% of the year. That's a high percentage still. For this far into solar cycle. So 63% is quite a high percentage. It's comparable to last year, 2019, where we had 281 days without sunspots. That was 73% of the year. So it's all telling us, isn't it, that solar activity is increasing. Yes, we are like a year into solar cycle 25. So solar activity is increasing, as you'd expect, but probably still at a reduced level compared to what you expect. Remember, the reason we look at solar activity, we explain this in the 7th winter update, which you will have to go back and watch, particularly part 2 of the 7th winter update, which was a shocker. Early on in a new solar cycle, you do have an increased chance of a colder winter when you are coming out of solar minimum, possibly when you're coming out of a prolonged solar minimum as well. Thank you to James and thank you to Richard for all of that data. Right, ocean data next. So this is how the oceans were looking when we did last week's 11th Winter 2020-21 update. So this is as of the 13th of November. We've got our 4 areas of interest. We've got the Enso region just here. We've got the Northern Pacific over there, and particularly the Northeastern Pacific. We've got the Indian Ocean just here, and then we've got the North Atlantic Ocean over there. Right, so that is how how the oceans were looking last week. Let's look at the very latest then. This is the very latest. Here it is, here it is, here it is. That's it. That's the very latest then. So let's deal with the Enso region first of all. So, of course, we've got this big mass of blue, which is cold and average sea surface temperature anomalies through the Equator-Pacific. That's a signature for La Nina. That is a signature of La Nina. You can see the La Nina stretching across the equatorial Pacific Ocean and extending down like off the coast of Peru and Chile, for example. Right, so how does that compare to last week? Let's go back to last week, since that's how things looked last week. This is this week. So I think you've possibly seen a little bit of a cooling over here in the eastern part of the Equatorial Pacific. I think it's continued to get ever colder in that eastern part of the Equatorial Pacific. Probably very little change through like the central part of the Equatorial Pacific just here. Very little change through the western Equatorial Pacific either. I think it's really in this eastern portion of the Equatorial Pacific that we are continuing to see those sea surface temperatures getting ever colder. La Nina will be with us for this winter. It is going to be a La Nina winter. The only question is exactly where the La Nina is. Is it central base? Is it eastern base? Is it a mix of two? And how strong will the La Nina be? Let's deal with the Northern Pacific next then. So this is how the North Pacific looked last week. And remember, we're particularly focusing up here in the northeastern Pacific. That's how things looked last week. This is this week. I think we've seen a further cooling of sea surface temperature anomalies here in the northeastern Pacific, particularly near the coast of Alaska, Canada, and North America as well. So particularly around here, we've seen a cooling, I think, but possibly also even into, so that's like shallow waters, which is prone to temperature, drastic temperature change with the weather conditions, but possibly even in the deeper waters of the northern and northeast Pacific. I think we might have seen a bit of a cooling actually on last week. We're still significantly above average, don't get me wrong. But I think you can see there is slightly less orange and red this week compared to last week. So a bit of a cooling is taking place again in the northeastern Pacific Ocean. That could be encouraging if you want a colder winter if it progresses. Of course, it's getting very late on now for this to progress. We're waiting to see if that gets colder, because over the past years it has been very mild and it's been warm there, and that tends to send the jet stream on a northwest-southeast alignment across America, and then the jet stream tends to come out into the Atlantic, blows up cyclogenesis around here, and pushes over into northern Europe as a very strong and intense jet stream. So if you want a colder winter, you possibly want this area to go a little bit colder. It is cooling, I think, but perhaps not quick enough to really do much for this winter. In the Indian Ocean, that's how things looked last week. Remember, this is the area we're looking at now, so that's how the Indian Ocean looked last week. This is how the Indian Ocean looks this week. So very little change, really. It remains generally warmer over here. It remains a bit cooler over there, but I don't think it's changed greatly over the last week. Possibly it has cooled down a little bit through here. I think we're still, certainly for the first part of winter, I think we're still channeling like a neutral to negative IOD, Indian Ocean Dipole, possibly changing to a positive IOD later in the winter. But if it does change to a positive IOD later in winter, it will probably be too late, really, to impact the winter of 2020-21. So I would expect the Indian Ocean, the IOD, to be a particularly big player either way for this winter. You want to know about the IOD, you have to go right way back to the very, very first winter update that we began with. Can you believe it? It was on Sunday, the 7th of September, I think, or the 6th of September, so long ago now, but you have to have a look at that if you want to know about the IOD, because I don't have time to explain it in this one. And then in the North Atlantic, again, this is how the North Atlantic looked last week when we did the 11th winter update last week. That's how the North Atlantic was looking. This is how the North Atlantic looks again this week. Very little change, really. Tropical Atlantic remains pretty warm, warmer than average anyway, and over towards southeast parts of America. It's cooler here in the northern Atlantic Ocean, and then just south of Greenland over to the Norwegian Sea, particularly around the Norwegian Sea, it is warmer than average through there as well. We're probably going to look next week one last time at the archives and see how we're doing, you know, with the Atlantic sea surface temperature anomalies at the moment compared to previous years all the way back to 1985. That will be in next week's final 13th and final winter update. This says the temperature change over the past 7 days, so you can see that yes, clearly we have actually turned things cooler up here in the northern Pacific. So we have seen the temperature, you know, sea surface temperatures cooling in the northern, northeastern Pacific Ocean. A mix of conditions, a mix of change, I suppose, for the equatorial Pacific. One or two areas getting cooler still, some areas getting warmer still. In the North Atlantic, generally things have got a little bit cooler over the past week, particularly around here. Maybe warmed up a little bit up there, but I think the main change actually over the past week, and in the Indian Ocean, by the way, so that area has cooled, this area has warmed a little bit. I think the main change though is up here in the northeastern Pacific, where clearly things have got quite a lot colder over the you know, over the past week, over the past 7 days. That is the 7-day change. This is from TribalTidbits.com. This is showing the daily sea surface temperature anomaly and how it's changing in the central part of the equatorial Pacific Ocean. So you'll remember, like back at the beginning of these winter updates, we would have been around here at the beginning of December, only just on borderline sort of La Nina type conditions. But through the autumn, the La Nina has been strengthening, particularly through October. The La Nina went down to a moderate to almost borderline strong level, actually going down to around 1.7 degrees below average. In November, the La Nina, you know, has been weakening through the central part of the equatorial Pacific Ocean. So we go from like being around 1.7 degrees below average around the turn of the month to by the middle of November being there around 1 degree below average. Where we are right now, each one of these blue dots represents an individual day sea surface temperature anomaly. Where we are right now is just there. So has the La Nina peak? That's the question. It's in the central part of the equatorial Pacific Ocean. Did the La Nina peak early around the beginning of November just here? Was that the peak of the La Nina? And we're just going to hover around there and then probably tick up as we go into the latter part of winter? Or will we see the La Nina re-strengthening again with the anomalies going down to that sort of area? It will be interesting to see. At the moment, we're sort of weak to borderline moderate with the La Nina, and it'll be interesting to see how that is looking next week. Right, let's go pull this out. This is CFSV2. So CFSV2 is continuing to forecast La Nina to be a strong event. It has backed off like a super Nina, but it is still forecasting by January that the sea surface temperature anomaly in the central part of the equatorial Pacific Ocean will be down to around 2 degrees below average. I still think that's going to pull up. I still think it'll finish up around there, around 1.5 degrees below average, but it will be interesting to see, won't it? But the La Nina the CFS has shifted from its super Nina to a strong La Nina forecast. This is how the Southern Oscillation Index is looking. This is from Queensland Government measuring air pressures in the Southern Ocean. So it's measuring air pressures between Darwin and Tahiti. When the SOI is in its negative phase, then the atmospheric setup will be reflective of El Nino. When the SOI is in its positive phase, the atmospheric setup will be reflective of La Nina. We're in a La Nina at the moment, so you expect the SOI to be positive, and indeed it is. We've been getting many days of positivity of the Southern Oscillation Index. So these are columns here for Darwin and for Tahiti as well. And then this is the SOI number just here. So for example, on the 18th of November, we was at plus 20.10. On the 17th of November at plus 17.69. And on the 19th of November at plus 20.17. Very positive Southern Oscillation Index. But the more recent days have actually not been quite as positive. 20th of November is at plus 16.86 and 21st of November at plus 2.86 as well. So the Southern Oscillation Index in terms of a 30-day average is looking like this. So last week or a couple of weeks ago we saw it down here. Now it's up here. It's a positive SOI. You would expect the SOI, the Southern Oscillation Southern Oscillation Index to be positive at this time of the year, because we've got a La Nina. So, of course, if we've got the La Nina that we have, then the atmosphere is going to be solidly in a La Nina type state. Which is not a very strong La Nina signal, though, within the atmosphere. You know, we're not going to plus double digits at the moment, anyway. We're not. So this probably suggests like a weak to moderate La Nina to me in terms of the atmospheric setup, rather than a strong or a super La Nina, such as the CFS is forecasting. If we're going to get a super La Nina, I would have thought we'd see the SOI 30-day average, you know, into plus double digits. But we shall see about that. This is, again, this is kind of related to C7 temperatures, particularly in the Atlantic. This is the 2020 Atlantic hurricane season page from Wikipedia. And we can see that it says, look at this, the 2020 Atlantic hurricane season is now the most active Atlantic hurricane season on record, with tropical cyclone formation at a record-breaking rate. A total of 31 subtropical depressions, 30 tropical storms, 13 hurricanes and 6 major hurricanes have formed throughout this season. It is the second season to use the Greek letter storm naming system, the first being 2005. Let's have a look then. Let's have a look at the scores on the doors. And here they are. So we have got, or we have had 31 depressions, 30 tropical storms, 13 hurricanes, and 6 major Category 3 or above hurricanes. What an incredible season. What an incredible season this has been. Absolutely unbelievable season. This has been updated by Shryan Brewing. This is showing ACE. Of course, this is what our analogues last week were based on, that moved the swingometer so very, very dramatically in favour of a cold winter. So ACE is kind of like the energy that these storms and that are giving off. It's categorised as below normal, near normal, average, below normal, near normal, also above average and hyperactive. So we go all the way back to 1851 with this. Let's scroll down. If you want to know which years were hyperactive for ACE, have a look at last week's 11th winter update. But anyway, this is how ACE is currently looking. So as of the 21st of November, our ACE is standing at 179.80. That is after 30 tropical storms, 13 hurricanes, and 6 major hurricanes. Obviously, that means we are hyperactive with this hurricane season. Where we fit in now, in terms of the table, is quite a long way up, actually. So this is like our very first hyperactive hurricane season in 1955. That's like the weakest, I suppose, the weakest for ACE. Where we are right now is just there at 179.80, and so we are somewhere between like 2003 and 1878. 1878 is a very, very interesting year, because of course that is followed by a severely cold winter for 1878 to 1879. Above that is 1887. That's another cold winter, and particularly brutally cold around Christmas. We're not going to like reach the very strongest, so we're not going to get to like 1933 and 2005 and these numbers that are well in the 200s. At least I don't think we are. So we're going to finish up. It's a hyperactive hurricane season, and we're going to be there or thereabouts, but it's not going to be like the very strongest in terms of ACE and hyperactivity for this hurricane season. Thank you so much to Shryan for the update. Right, I'm going to pause the video there for the same time, and when we return, we're going to look at Eurasian snow cover and the Quasi-Biennial-Oscillation. So, again, go and stretch your legs, get yourself another little cup of tea or whatever you like to drink and some nibbles, and we'll be back very, very shortly with the final section of the 12th Winter 2020 Update Part 1. I'll see you soon. Okay, we're back, and we're ready to resume the 12th Winter 2020 Update Part 1. the last section of it. So if you enjoyed this video so far, please give us a like. Let us know in the comments what you think, and make sure you subscribe to the channel. It's absolutely fantastic. Thank you so much, everybody, for doing that. Right, so we're going to look at Eurasian snow cover next. So this is how Eurasian snow cover looked last week when we did last week's 11th winter update. So we had the snow line just there into like the west of Russia, but not into the far west of Russia, and Scandinavia looking very, very bleak, doing very, very poorly for snow. This is the latest, for Saturday the 21st of November. You can see that we have had major gains in snow cover. The snow line has pushed westwards and is in fact now almost pushing into the gates of Europe, or is pushing into the gates of Europe. So major gains for snow cover across Siberia, and very significant gains over the past week in terms of snow cover through much of Scandinavia as well. Very impressive gains for snow cover over the past week compared to last week. That is quite a big increase. Right, let's see how that compares then. So this is how things looked on this day in 2019. So I think we're probably on a par with 2019 for both Russian and also the Scandinavian snow cover. Maybe a little bit ahead. That's how things looked in 2018. We're probably behind for Russian and European snow cover this year, 2018, but we're ahead for Scandinavian snow cover. That's 2017. I think we're probably behind for 2017 for Russian, and definitely behind for Scandinavian snow cover. That's 2016. We are behind 2016 for both Russian and Scandinavian snow cover. That's 2015. I'm going to go through these very quick. That's 2015, which we are behind for both Russian and Scandinavian snow cover. That is 2014, which we are ahead of. We're ahead of 2014 at this point for Russian and Scandinavian snow cover. That's 2013. So we are ahead of 2013 for Russian snow cover, and probably quite closely matched for Scandinavian snow cover. That's 2012, so I think we're quite closely matched to 2012 actually for Russian and also the Scandinavian snow cover as well. That's one of the closer matches. 2011, we're behind 2011 for Russian snow cover, but we're ahead of it for Scandinavian snow cover. That's 2010, we're behind now 2010 for both Russian and also Scandinavian snow cover, particularly for Scandinavian snow cover. That's 2009, what do we think about that one? We're probably quite closely matched actually to 2009 for Russian and also Scandinavian snow cover. That's 2008, so what do we make of that one? I think for 2008 we are probably a little bit behind for Russian snow cover, near matched for Scandinavian snow cover. That's 2007, well behind 2007 at this point for Russian snow cover, and probably behind for Scandinavian snow cover as well. That's 2006, we're behind for Russian snow cover, 2006, probably near match for 2006 for Scandinavian snow cover. That is 2005. So 2005, I think we are behind for both Russian and for Russian snow cover, probably quite closely matched for Scandinavian snow cover. That one is 2004. We're well behind 2004 now. Look how far into Europe the snow line had pushed at this point in 2004, all the way to Germany. So we're well behind 2004 for Russian and European snow cover. For Scandinavian snow cover, we're behind for that as well. That's 2003. We're behind 2003 for Russian snow cover, probably ahead though for Scandinavian snow cover. That's 2002, so I think we're behind 2002 for Russian and Scandinavian snow cover. That's 2001, we're behind 2001 for Russian snow cover, and probably behind Scandinavian snow cover as well. That's 2000, we are ahead of 2000 for Russian snow cover, and probably ahead for Scandinavian snow cover as well, I would have thought. And then that's 1999, which are well behind. Look at that. The snow line are pushing into France at this point in 2009. Crazy. And also across Scandinavia, we're behind for both Russian, European, and Scandinavian snow cover as well. That's 1998. So again, with that one, definitely, I think we're behind 1998 for Russian, European, and also Scandinavian snow cover. Going even further back, you've got to tilt your head round and stand on your head for this. So this is how things look this week in 1997, with a high 1997 for Russian and Scandinavian snow cover. That's 1996, with a high 1996 for Scandinavian snow cover, but probably ahead for Russian snow cover. Remember, we've got this yellow area, that's where we've got snow. Or browny yellow. That's 1995. We are behind. We're behind 1995 for both Russian and also for Scandinavian snow cover. That's 1994, which we are behind as well. That's 1993. Look how much of Europe was covered in snow in this point in 1993. That's a very cold November, of course. And so we're well behind 1993 for Russian European snow cover, but maybe ahead, interestingly and bizarrely, maybe ahead actually of 1993 for Scandinavian snow cover. That's 1992, which we are behind. That is 1991. We're behind for Russian and Scandinavian snow cover for that one. That's 1990. We're probably quite closely matched, I think, for 1990 for Russian snow cover, and probably a little bit ahead actually for Scandinavian snow cover. That was a cold winter, of course, 1990, 1991. 1989, we're behind that one quite clearly. We're also behind 1988 for Russian snow cover, but ahead for Scandinavian snow cover. That's 1987, which we are behind for Russian and Scandinavian snow cover. That's 1986, so we're ahead of 1986 for Scandinavian snow cover. We are probably behind, though, for Russian snow cover just. That's 1985, we're behind that one quite clearly. That's 1984. What do you think about that? Probably quite closely matched to 1984 for Russian and also Scandinavian snow cover as well. That's another cold winter, 84, 85. 1983, we're behind that one. 1982, so we're ahead of 1982, definitely, for Russian snow cover, and probably ahead for Scandinavian snow cover as well. That's 1981, we're behind that for Russian Scandinavian snow cover. That's 1980, we're behind that one too. That's 1979, probably quite closely matched for Russian Scandinavian with that one. That's 1978, so we're probably, and this is followed by another cold winter, we're probably quite closely matched to 1978 for Russian snow cover, maybe a little bit behind or near normal for Scandinavian snow cover. Interesting. That's 1977, we are behind 1977. We're also behind 1976, which happened all the way through the season. We're behind 1995 for Scandinavian snow cover, probably near match for Russian snow cover. That's 1974, we're behind that one. We're behind 1973, we're behind 1972, we're behind 1971, we're behind 1970 as well. That's 1969, we're behind that one also. Well behind 1968, the snow were pushed into France at this point in 1968. Incredible. Last year is 1967, so we're probably behind 1967 for Russian snow cover, and ahead, though, for Scandinavian snow cover. I hope you found that interesting and informative. The last thing we're going to look at is the QBO, the Quasi-Biennial-Oscillation. So just to confirm that we are in the westerly phase of the QBO now. So you'll remember that we should be in the easy phase of the QBO. Back at the start of the year, the Quasi-Biennial-Oscillation was in its negative phase. So we should have seen that increasing and powering up, going into an easterly QBO. What actually happened is that the easterly QBO failed through the summer. As we've gone into the autumn, the westerly QBO, the positive numbers, have come back. Remember, the QBO is just a way of indicating how strong the zonal westerlies are. So when you're in a westerly QBO, the zonal westerlies will power up. When you're in an easterly QBO, the zonal westerlies will weaken. So basically, when you're in an easterly QBO, you have a better chance of a colder winter because you have weaker zonal westerlies and zonal winds, and you should get more blocking. Not always that straightforward, though, because very often the easterly QBO does go along with a mild winter as well. So we had a failure of the easterly QBO through the summer. We have gone back into the westerly phase of the Quasi-Biennial-Oscillation. So just to say that, like, there are years where the easterly QBO has struggled to get going. So, for example, 1988 to 1989, we see the easterly QBO just sort of at a very reduced level, very, very low level, with these slightly negative numbers. Around a year, it took around a year for the easterly QBO to really get going from 1988 to 1989, but eventually the easterly QBO did power up through the second half of 1989 and into 1990. That's a very mild winter, of course. The other time this has happened was in 1964, Again, we can see that in 1964, we begin 64 with like a weak westerly QBO, then it reverses into a weak easterly QBO or near neutral, and you just see how these sort of slightly negative numbers, but never really going properly negative, continue for many, many months through the second half of 64 into early 65, and then mid-1965, the easterly QBO really starts to power up, and that takes us through 65 into 66. So that's like that's like not a failure of the ECQBO, but the ECQBO is struggling to get going. However, what has happened this year is like a failure of the ECQBO. And as far as we can ascertain, the only time that has happened, we've only been measuring the QBO since 1950, but as far as we can ascertain, the only other time that happened was in 2016. So in 2016, we begin with a westerly QBO. We see it reducing, but never going negative, never going into the ECQBO, but it does reduce and should have gone into an ECQBO, but wasn't able to, and then westerly QBO just powered up through the second half of 2016 and into 2017. We did actually make it into an ECQBO this time. That's what's quite strange about this, that we did see the ECQBO actually developing and powering up through the first months of this year before, like, reversing. So very, very strange what has happened with the Quasi-Biennial-Oscillation this year. This is how it looks at the University of Berlin. I haven't shown you this in the winter update so far, but I thought we would do for this update, as it is a bit of a QBO special. So where we've got these darker areas, this is the westerly QBO. Where we've got the white areas, that's the easterly QBO. So you can see, this is the dates, of course, 2020, 2021, next year just there. You can see that we did make it into the easterly QBO. We did make it into the easterly QBO just for a couple of months. Early in the year, we see like white right from the strat up there at 10 HPA all the way to the surface. But then, very bizarrely, strangely, which probably never happened before, back to 1950 anyway, we see the westerly QBO just coming back and strengthening. However, what this does show is that we still have the easterly QBO at the top of the atmosphere, in the stratosphere, just here, and we have it low down as well through here. So it really is like, the westerly QBO really is like in the middle of the troposphere, actually, in that sort of level. But because we've got, this is a theory I saw Matt Hugo on Twitter talking about, because we've got the easterly QBO top and bottom, it is possible that that's going to act as a bit of a cap on the effects of this westerly QBO. This is from NASA, so again, this is showing like how the QBO is currently looking. So where we've got these blue-green areas, that's the easterly QBO, that's the last easterly QBO phase, of course, from 2017 2018. This is the westerly QBO from 2018 to the beginning of, to the end of 2019. And then this should have been the next easterly QBO. That should have been the next easterly QBO, descending from the stratosphere into the troposphere and then down to the surface. But in the troposphere, the westerly QBO developed and powered up and kept the easterly QBO penned in at the very top of the strat. However, if we zoom in, you can see that at the top of the stratosphere, at 10 HPA, this easterly QBO is still there, and it is, you know, getting stronger. The easterly QBO is getting stronger at the top of the stratosphere. At 10 HPA, the easterly QBO, indicated by those darker blue bars, is developing, and it is getting stronger. And so as we've got an easterly QBO up here, and we've also got like easterly QBO down here as well, this could act, it could do, it may not do, but it might act as a cap on the westerly QBO, which is actually like in the middle of the troposphere. It may stop this westerly QBO from having too many impacts. That said, we are going to have to look, I think, definitely at winters that have a westerly QBO. And I think because of what's going on at the top of the atmosphere in the stratosphere up here, where the easterly QBO looks to be getting stronger again, I think we're also going to have to look at winters that go from a west to an east QBO. So that's what we're going to be looking at in part 2 of this 12th winter 2020-21 update. Tomorrow we'll be looking at QBO winters with our analogues, and there'll be westerly QBO winters, and there will also be winters that transition from a westerly to an easterly phase of the Quasi-Biennial-Oscillation. But I certainly wouldn't rule out the chance that this ECQBO is going to power up. And even if it doesn't affect things in the winter, so it may take a while to push down in the troposphere next year, I think this ECQBO will finally get going. Okay, so if you enjoyed this 12th Winter 2020-21 update part 1, please click like on the video. Make sure you subscribe to the channel, and don't forget to tell your friends about GavsWeatherVids. If everybody who subscribes brings a friend, then we're going to get to 9k subs so much quicker. Thank you so much, everybody, for doing that. Right, okay. That's it, 54 minutes. I think that's the longest winter update that we've done so far. So just say this video will be placed on the winter updates page. There'll be a written summary that goes with it as well. You'll be able to have a read of that probably tomorrow morning and watch the video on demand at GavsWeatherVids.com. It's also going to be kept on the YouTube channel forever as well, of course. We're going to be back later on with the ECODF Metro France DWD and GMA seasonal model update. That'll be around mid-afternoon. And then 6 o'clock tonight, we're going to be live streaming. So I shall see you then. No doubt we'll be discussing this winter update and so much more too. So I shall see you at 6 o'clock with winter data from the CFSV2. But for the 12th Winter 2020 update part 1, that's all for now.